Alright, here we are with the last lesson in Unit 1, Lesson 116, Describe Geometry Part 2. And again, I just want to encourage all y'all to please put your course number and your section number on all communication with me, IMs and KMails, so I can help you faster. The objectives that we're going to go over in this lesson are using algebraic operations on the coordinates of a pre-image to perform translations and reflections and rotations. Use algebraic notation to describe transformations in the coordinate plane. And describe the result of an algebraic transformation. That all sounds really hard, but it's going to be easy. Or at least I hope it's going to be easy for you. We're still using the terms pre-image and image. Your pre-image being the original figure, and the image is the result of the transformation. For those of you who were in CC yesterday or have looked at the slides, you saw these rules for transformations. All of those objectives, we're talking about this. This is what we're going to be learning today, how to use these rules. Okay? Whenever you have a translation, you're always adding or subtracting something to the x and or y coordinates. And when you have reflections, there's always certain rules that you can follow whenever you're going across the x-axis, the y-axis, and the x equals y line. And then for rotations, there's little certain rules. If you're going 90 degrees, this is going to be your rule, and so on. But it's easier to show you examples than to sit here and talk about them. So let's go. Alright, first it says write the ordered pair that represents the image when each point is reflected, and I'm going to put across the x-axis, and I copied that rule for a reflection across the x-axis. If you look at this rule down here, it says whenever you've got x and y and it's reflected across the x-axis, the x value will always stay the same, the y value will become opposite. Okay, so just let that sink in for a second. Your x value will stay the same, your y will become the opposite sign. So right here you have a 12, it will stay a 12, this -7 will become a +7. Here you've got a -9, it's going to stay a -9, but this +10 will become a -10. Okay, so your y is always going to be the opposite change, your x's will stay the same. So these x's aren't going to change, but this -4 will become a +4, 0 is going to stay 0. It can't change. And a +15 is going to become a -15, so let's take a look at that. See how the x values stayed the same? The y's became the opposite sign. X values stayed the same. Opposite sign. And again 0 stays the same. And then 15 to a -15. I put down here, note that when you go across the x-axis, the x's stay the same and the y's become opposite. It only works when you're going across the x-axis. Okay, so let's look at the y-axis. Here's your rule for reflecting across the y-axis. Your x's will become the opposite sign, your y's will stay the same. So -7, 10, -4, 0, and 15, those are all going to stay the way they are. However, you've got a 12 will become -12, -9 will be +9, 11 will be -11, and so on. So let's look at those answers. And you can see here how your x's became the opposites, your y's stayed the same, and I put the same kind of little note down here. Whenever you're going across the y-axis, x's become opposite, y's stay the same. And just remember, when we're talking about opposite, that means the opposite sign. If it was positive, it's going to be negative. If it was negative, it's going to be positive. Okay, let's look what happens when it crosses over the y equals x line. Now, you've got to remember, if you were to set up a line on a graph where y equals x, you would have a line with these points 0, 0, 1, 1, 2, 2, 3, 3, and it would make a line going exactly diagonal across a graph. Well, I'm going to be reflecting from one side of that line to the other. Whenever you do that, nobody is opposite. It's just x and y switch spots. So 12, negative 7 will become negative 7, 12. Negative 9, 10 will become 10, negative 9, and so on. So let's look at these answers. See how they just flipped? They just flipped right here. And over here, 11 and negative 4 becomes negative 4 and 11. Negative 7 and 0 becomes 0 and negative 7. Negative 6 and 15 becomes 15 and negative 6. So anytime you go over the y equals x line, the x and y just trade places. Okay, they do a switcheroo. Okay, let's look at some, I guess you'd call them real world examples. It says Juan is creating a mosaic. The points on the grid represent the blue tiles, and here's your blue tiles. To make his design, he will rotate the points 90 degrees counterclockwise around the origin until each quadrant of the board has a set of 6 blue tiles. Now, what I want you to realize is counterclockwise, you know, if the minute hand on your clock goes this way. Okay? O1 here is going to be translating these points to go counterclockwise. Okay? So part A says, what coordinate rule can one use to repeatedly transform the points? Okay, now we haven't gone over this one yet. Let's go back right quick. Well, let me see if I can do it this way. We're on slide 12. Dun, 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 dun. Let's go to slide 5. Oh, I'm good. There we go. This is what he's doing. He's doing a rotation about the origin, and he's going to translate them 90 degrees counterclockwise. So here he could go 90 degrees, and this is where his y values are going to stay the same. Oh, wait. Let me see. His y values are going to stay the same, but oh my goodness. My brain just got twisted. Sometimes it does that with rotations, and y'all thought reflections were kind of tough. If I'm going counterclockwise, let's see what it says. It says one can use the rule. Okay, I was right the first time. One can use the rule x equals y translates to negative yx. So see, not only do they the y's become opposite, they flip spots. So let's go back and look at the rotation. I think it was slide 5. There you go. So it was the first one that I picked out. I just let myself get confused. Okay? This is the rule we're using right here for Juan's mosaic tiles to go counterclockwise. There we go. So that's the only answer. We didn't have to graph anything. Let's look at B. It says, since he's working in the counterclockwise manner, in what quadrant will the next set of blue tiles be placed? Well, you think about it. If he's going counterclockwise, he's going to be going from quadrant 3 to this quadrant, which is quadrant 4. So this is what I put up here for B. The next set of blue tiles will be placed in quadrant 4. Now if he was going clockwise, they would have ended up in quadrant 2. C says, use the coordinate rule to transform each point until each quadrant has blue tiles. And it'd be kind of hard. My pen won't let me put points on here, and I don't want to sit here and make a whole bunch of points, so I just put the new grid up here. Okay, so here's his original blue tiles. He rotated it 90 degrees counterclockwise, and he ended up in quadrant 4. Now each time he used this rule. So here's what all of his points were. in quadrant 3 if you plotted each of these points right here. And when he used the rule, he made x and y flip places and the y became opposite. So -2 became +2. The -5 went to the y spot and stayed the same. So here I've got y is a -3. It becomes the opposite, which is +3, and the x -3 stays the same and goes to the y position. Anyway, it goes all the way down there like that. So here he is in quadrant 4. He's got to take it 90 degrees counterclockwise, and it'll end up in quadrant 1. So he took these points and flipped them and made y the opposite, and then did the same thing for quadrant 2. It's kind of interesting. Okay, this one says draw the result for each transformation. The first one says translate the figure HIJK 6 units up. Well, I'm going to see if I can do something here. I just thought of something. Okay, so if I'm going to go 6 units up, I'm going to go 1, 2, 3, 4, 5, 6. That's going to be my new H. Look at there, I did a point. So here's K, and I'm going to go 1, 2, 3, 4, 5, 6. So there's my new K. 1, 2, 3, 4, 5, 6. There's my new I. And then J is 1, 2, 3, 4, 5, 6. And then if I wanted to, I could just kind of change my color here a little bit. I could go ahead and connect my points. Got some real fat lines going there. And you can see how it translated up. And let's see if I got her correct. I sure did, looky there. And the points are named as well. You always put that little apostrophe for your image. Oh goodness. Okay, let me go back one. It says translate the figure HIJK 2 units down and 3 units to the left. Now when you're going to work a problem like this is where it's nice to go ahead and write your rules out. We're going to have X, oh let me make that a little bigger so we can all see it. I'm going to have X and it says going down, which means I'm going to subtract 2, and then Y, oh wait, sorry about that. They worded it funny. I'm going to be going to the left 3, so I'm going to be subtracting 3. And then my Y, oops, I'm going to be subtracting 2. Okay, because when you're going down, that up and down represents Y, left and right represents X. Whenever you're going left or down, you're always subtracting. So let me go back here and see if I can do this. I'm going to have X minus 3, so there's going to be an H right there, and then I'm going to go down 2. Let me get rid of that 1 point because I don't want to confuse myself. So that's my new H. My new K, I'm going to go to the left 3, down 2. Oops, lost my line. I got to do it again. Over 3, down 2. And then for my I, I'm going to go the left 3, down 2. For my new J, left 3, down 2. And that's my points. So let's look at the answer and see how I did. Looks like I did pretty good. Over 3, down 2. Yep, I got it correct. Okay, let's look at this example. It says use the rule to transform the figure. You're going to take this XY, you're going to make the X be the opposite sign, and your Y is going to stay the same. So if you look at point A, its X value is -2 and its Y value is a +3. So my new point A is going to be a +2, I'm going to come over here and my y stays the same. Okay? So I'm going to go ahead and do these points up here this time. I had my x value was a -2, my y value was a +3, and I forgot to put parentheses over here. Oh, my new point A is going to be +2, let's put parentheses this time, and a +3. Okay, the x value became opposite and the y value stayed the same. So for point C, it's going to become a +3, and my y is going to be a -2. And I'm looking, there's no way I'm going to have enough room to do all these. Well, my C shouldn't be like that. Okay, it should be. My mind was, I was blowing my own mind again. Here we go. So my C is going to become a +3 with a -2. My B right now is a +2. It's going to become a -2, and my y will stay -3. So there's my new triangle. Let me come up here. I'm going to change my line here a little bit. So it said use the rule to transform the figure, and what they should have said is what kind of transformation is it? Well, if you look, it looks like it's being reflected over the x-axis. Okay, because remember what the rule says, when you go over the x-axis, your x's will be, your y-axis, over the y-axis, your x's will be positive and your y's will be the same. So I'm going to put that over here, reflected across y-axis. I don't know why I'm doing this, because it's all on the next slide, but there we go. Alright, what we've learned in this lesson is an ordered pair of coordinates can describe the location of any point on a regular grid. You can use algebraic methods to perform transformations on figure with known coordinates, and reflections across axes and rotations about the origin. Keep the values the same, but change some or all of the signs. And when you get done here, you need to go ahead and get into the LMS and read through lesson 116. Complete the study guide, and as well look through the pages 27 through 30 in your book. Complete the following problems in your problem set, and they're all just like the problems I just did, really quick problems. Contact me or attend TOGA. Well, we don't have TOGA tomorrow, so be sure to contact me if you don't understand any of the concepts, and make note of any general questions you may have for when you attend CC on next Thursday. And your next video will be your Unit 1 test review, and I will talk to you guys later. Thanks for listening.